So this section I'm gonna explain chapter 4. So let's start. I know most of you had doubt with chapter 4, so I'm making a video regarding how to go about this. And let's do section 4.1. We are talking about exponential functions. What exponential functions are? How do you write exponential functions? It's something as fx is equal to b to the power of x. That's how it's written. B, and it is raised to power x. So it's b, on the top it's x. That's how it's written. And there's special condition. X can be any real number. X can be any real number. But b, there is a condition on b. It's supposed to be greater than 0. It can be any number which is greater than 0, 0 0.5, 0 0.6. But also there is a condition that it cannot be equal to 1. So it can be any number greater than 0 but not 1. It can be 2, 3, 4, 5, 2.5, 6, 8, 8.10, anything but not equal to 1. So the questions on this, that's how the thing you're gonna get is, okay, graphing. I'm gonna skip on graphing, but yeah, let's come to this thing here, compound interest. And this thing, what I want you to learn is, important thing is compound interest formula. Compound interest formula. So in this thing, basically think as a, you are a person who's investing money in the bank. Okay, the amount you're investing in the bank is known as principal amount. Principal amount, which is denoted by P. So that is the amount you are depositing in the bank itself. You are going and putting in the bank. That's principal amount. For how much time are you depositing? 3 years, 4 years, 5 years. It's usually in years. Okay, it's usually in years. So for how long you have deposited that money? I have $100,000. I go and deposit for 5 years. So my P is 100,000 and time is 5. T becomes 5. And then there is something known as R, rate of interest. Rate of interest. What does that mean is, okay, I'm putting my money in the bank. Bank is supposed to pay me some interest. They can use my money for anything they want. My money is there in the bank. They're supposed to give me some interest on it. That's known as rate of interest. Usually it's in percentage given, but you have to convert into decimal. How do you convert into decimal is dividing by 100. So if I say, for in the formula, it will be given to you, the rate of interest will be given to you in percentage, but you have to convert into decimal. So if I say 6%, if I say convert into decimal, what is it? Divided by 100. 6 divided by 100, when you do in calculator, it becomes 0.06. So whenever it is given rate of interest, it will be given in percentage and you have to convert into decimal. Then there is something known as N. N. How many times is my amount, compounded? How many times is my, in a year, how many times is my amount being compounded? It is different in different cases, which you have to remember. N is equal to, let's see, N will be equal to 2 when it's semi-annually. Okay, it is equal to 4 when it says quarterly. Okay, N is equal to 12 monthly, and N is equal to 365 when it's daily. You have to remember these things. You have to remember these things. Okay, that's what it is. And A, it is known as amount. It says, what is this? A is what you get after so many years. So if I say I deposited 10,000 in the bank for 5% for 3 years, 10,000 I'm depositing, that's my P. For 5 years, that's my T. Rate of interest for how long? 3%, that's my rate of interest. And N, A will be how much amount at the end I will get. So after 3 years, if I go to the bank and take out my amount, how much money I'm getting, that's the amount. So we are going to use this, and the formula for this thing is A is equal to P 1 plus R over N, and then on the top N times T. That's the formula. So whenever you're using this formula, make sure first you divide R by N, add 1, whatever answer you get, raise to power, multiply N and T, whatever answer you get, you raise to power that thing and multiply by P. That's how you get it. So let's see a question on this. Let's see a question on this. So if you see here this problem here. So I'm going on page number 473. I'm on 473. So this thing is page 473. So if you go read this question, you decide to invest 8,000 for 6 years. So you tell me, what is 8,000? You're depositing 8,000 for 6 years. So you are depositing 8,000. So this thing is your principal amount. 8,000 is your principal amount for 6 years. So 6 years. So 6 years is your time. So 6 becomes your time. This is my time here. Okay. It says you have a choice between two accounts. Okay. We have two options. Okay. The first pays 7% per year. So they are saying there is two cases now. Let's see. They are saying there is two cases. First case and second case. Okay. In the first case, they are saying you're depositing 8,000, which is your P, for time 6 years. In this case also, you're depositing 8,000 for time 6 years. But they say one is paying you rate of interest as 7% per year. Compounded monthly. When it's compounded monthly, what's your N? Compounded monthly. N becomes 12. So in this it becomes 12. But in this case, the next part, it says the second pays this much interest. So I know my R is 6.85%. And it says compounded continuously. Okay, now I haven't explained you this continuously part. Whenever they say compounded, semi-quarterly, quarterly, monthly, daily, this is the formula. This is a formula. But when it comes to compounded continuously, the formula changes. It's A is equal to P e to the power of R times T. In this case, we don't have N. E is the exponential thing. It's just raised to power R times T. If in your calculator, there is E. So you just put in there and get your answer. So in case of continuous, since in this part, the second problem is continuously, we need to use this formula. So we know the formula changes to this thing. You have to remember both the formulas. Okay, you got this thing. Okay, I told you I'm not gonna, my T should be in years. They both are in years. That's good. But here my R is in percentage. I have to convert into decimal. Okay, 7% in decimal. How do you convert the percentage into decimal? You divide it by 100. When you convert into 100, 7 divided by 100 is what? 0.07. So that's what you're gonna get. Here, 6.85. When you convert into decimal, what do you get? 0.0685. You have to convert rate into, don't start using the number exact the way it is given. You have to convert into decimal by dividing by 100. Put this in your formula here. You get A is equal to 8,000. 1 plus R is 0.07 over N is 12. And here it's 12 times. And T is 6. When you calculate here, use inside, find an answer. 12 times 6 is 72. Whatever you get, do the calculation, raised to power this, multiply by 800. When you do it, your answer will come out to be 12160.84. Use calculator to do this. So if I use this method, if I deposit in the bank 8,000 for 6 years at this much rate of interest for this compounded monthly, this much amount I'm gonna get at the end of 6 years. Let's see what happens in this case. 8,000 e to the power of R is 0.685 times 6. When you solve this, when you use a calculator and find this, you're getting 12,066.60. That's what you're getting. So when you're depositing for this much rate of interest, you're getting this much. When you're depositing for this much rate of interest, you're getting this much. Which one do you think is better? You are getting at the end of 6 years, you're getting this amount or this amount. Which one do you want? You obviously want the more amount. You want to get more amount. So that means this one is better. This one is better. So basically, this one is better. That's what you're going to say. See here it says the balance in this account after 6 years is this much, which is slightly less than the previous amount. See, this is less than this much. So that means the better investment is 7% compounded monthly. That's the better one. So that's what we did. If you want, try out checkpoint 7. And I know I gave you these problems 53 to 56. Go through them. So page I probably gave you 475, 53 to 56. Go through those problems. That basically is section 4.1. So that's all you are doing for section 4.1. Next thing we come to is section 4.2. Let's go through let me take another page. Okay. Let's go through section 4.2. Now we are coming to logarithmic function. Logarithmic function. So what is logarithmic function is, it's basically y is equal to log bx. So you have some y which is equal to log, and there is some base and there is some x. Base is at the bottom of log. So it goes at the bottom. You cannot write bx like this, it's at the bottom. So example, when it says you can write this logarithmic function in the form of exponential function also. How do you do it is, just take this, how I remember is, take this b here and raise this up and it equal to x. So it becomes b to the power of y is equal to x. This and this, they are the same thing. They will give you the same thing. They mean the same thing. This thing is in the logarithmic form. And this thing is in the exponential form. This is in the form of logarithmic. This is in the form of exponential. They are the same thing. They mean the same thing. So you can remember, you take this here and raise this power on the top. That's your exponential form. And if you take here down and add a logarithmic, it becomes the logarithmic form. So example, if I say 2 is equal to log 5x. 2 is equal to log 5x. I say write it in the form of exponential form. Now logarithmic form is given. I have to write in the exponential form. What does it become? I told you, take this here and make it on the top. Take it on the top. If 5 will come here, this 2 will go on the top is equal to x. And what is 5 square? 25 is equal to x. You don't have to solve it, but that's how you do it. Okay. Let's take one more example. It says 3 is equal to log b64. You have to write in the exponential form again. How do you do it? I told you, take this number, whatever is the base, take this here and this thing goes to the power. So it becomes b to the power of 3 is equal to 64. That's it. That's it. That's your answer. Let's see the third part. Third part. Let's say log 3, 7 is equal to y. Log 3, 7 is equal to y. Again, you have to write exponential form. How do you do it? Whatever is the base, take it to that side and this becomes to the power. So it becomes 3 to the power of y is equal to 7. That's it. That's all you have to do when you're converting from logarithmic to exponential. So we are converting from log to exponential. Okay. So what you can do is to practice this more. I would like you to do on page number 479, checkpoint 1. Go through those things. This will help you when you're starting this, when you're seeing this video. Stop this video. Stop here. Go through checkpoint 1, page 479 and see if you can get it or not. If you can get it or not. Try those problems. Okay. Next thing is converting from exponential to logarithmic. Okay, let's take one example. I say 12 squared is equal to x. I say write this in the form of exponential. How do you write this exponential? Go backward. This was not in the power. Get this thing down and this becomes your base and this remains x. That's how you do it. Let's take one more example. So you have b cube is equal to 8. Again, you have to write in form exponential. Remember, this 3, the power comes down. This b becomes your base and 8. So whatever the number is here underneath the power, that becomes your base and this thing comes down. Okay, let's see one more. E to the power of y is equal to 9. Again, this y will come down, log, and whatever is the number down here, that becomes your base and 9 will remain as it is. Again, try checkpoint 2. Stop the video here, try checkpoint 2 and see if you get it or not. Okay, that's one thing. Okay. Let's see in our, okay. Okay. One, while waiting. Okay. These few properties they want us to remember for logarithmic is, okay. So let's do some few properties of logarithmic. First property, okay, I'll write the properties here. Make a note somewhere in your paper. Make a note of these properties. First property it says is log base is equal to 1. It says no matter if I have the same number here, My b here, my base and the number here is same. That's always equal to 1. Example, I say, what is log 20? My base is also 20 and the number here is also 20. It is equal to 1. You should directly know it. If it's same, it's equal to 1. What is log 10? 1. That's 1. Okay, these are the properties. But one thing I want you to remember, some places you'll be like, it's just written log 10. What does this mean? What's my base here? They're not giving you base. When no base is given to you, there is actually a base. It is always 10. It is always 10. So if I say log 20, what is my base here? It's 10. Log 30, what's my base here? It's 10. If it's nothing given, you already know it is 10. When nothing is given, it's already 10. So what if I say, what's the value of log 10? You're like, I don't know how to calculate this. But remember, if it's nothing, it is 10, right? And I told you, when they both are the same, the value is actually 1. Okay. Similarly, there is something known as ln. What is ln? ln means log with base e. Whenever they say ln, that's log base e. Also remember, log is equal to log 10 and ln is log e. These are two important things. So whenever I say, what is the value of ln e? You're like, I don't know. What is ln? Log base e. So this e was there. So it becomes 1. So basically, ln means log base e. Just log means log 10. So you should know. Log 10 is 1 and ln e is 1. You don't have to write those steps, but you should know. Why is it 1? Is because the base is 10. And when these two are same, it's 1. Similarly here, base is e. When these two are same is 1. That's one property. Remember. Okay. Next property you're going to do is, when you have log any base, I don't care what my base is, but if here it's 1, here it's 1. Log any base 1, it is always equal to 0, no matter what. Example, if I say log 5 1, what is it equal to? What's the log 5 1? I told you, I don't care about my base, but if it's here it's 1, it's always equal to 0. Okay. Next property, so I want you to, after these two, I want you to try checkpoint 4. Go through checkpoint 4 and try that checkpoint 4. Next thing we're going to do is, another property is, what it says is, if you have log base to the power of x, it is always equal to x. So if you have log, the base is same and the b is raised to power x. If they both are the same, then it's always equal. Basically, remember, they cancel out and you're left with just x. So suppose if I give you log 4 to the power of x, what is it equal to? 4 to the power of 5. Let's take 4 to the power of 5. What is it equal to? Just remember, it's like it cancels, you're left with 5. What is log 10 to the power of 2? You tell me. Remember, you're like, oh, the base is not given here. What should I do? If no base is there, there is 10. So those 10 cancel, left with 2. Similarly, I say ln e to the power of 8. I say this thing. I give it an example. What's the value? You're like, what is ln? Log e. Log base e. That's ln. So if you put here log base e to the power of 8, they basically e cancels, so you're left with 8. So remember like this. Another fourth property you can remember is, which is b log bx. It's also equal. Now your log function is in the exponential and your base here and this number, they both are the same. They cancel, you left with x. Example you get here is, I say 6 log 6 9. What is this? The base is same here, also base they cancel, you're left with just 9. So what if I say log 8? What's the value of this thing? 10 log 8. I'm like, I don't know. What's the base if it's nothing? It is 10. So it comes out to be 8. They cancel. What about 20 log, I say 20 ln, e to the power of ln 5. E to the power of ln 5. You're like, I don't know this thing. What is it? E, this is basically e. Ln is what? Log e 5. So basically the cancel, you're left with 5. So remember these properties. Once you are done this, I want you to try checkpoint 5. Page 481. Try these problems. That's how you're going to get it. Okay. Graphs, you don't have to do graphs. We are not doing graphs. Okay. Domain and all, you don't have to go through domain. So from section, for section 4.2, these are the 4 properties that you're gonna be remembering. Okay, that's 4.2.